It's the Math 107 lesson number 2 demo. So there's some good news that it may be possible to answer a lot of questions that you weren't aware that you would be able to using mathematics. We can work with the real data collected and presented in the bar graph to find a mathematical model, or sometimes we just call it a model. A model is a mathematical representation, like an equation or a formula, of a real-world situation. And if we can describe the relationship between two or more quantities, we can also write an equation relating them. So this is an important step in problem solving, being able to convert a description into an equation. So let's use math to answer some questions about the number of US unauthorized immigrants from Mexico using a model of the data presented above. So I have I equals 0.007886x squared plus 0.160280x plus 2.007351. That equation models the number of unauthorized immigrants from Mexico for years since 1990. So X is the number of years since 1990. So I want to use the formula to estimate the number of unauthorized immigrants from Mexico in 2005. So the actual number of immigrants that can be found on the bar graph on the previous page, but we're going to estimate it using this formula. So I've got my calculator and I have 0.007886. Oops, I missed a 0. And then I have to multiply 2005. That is 15 years after 1990. So I'm doing x equals 15 here. So I'm going to replace each x in this formula with a 15. So times 15 squared plus 0.160280 times 15 plus 2.007351. And I get about 6.2 million. So this is about 6.2 million. So in 2005, the model estimates approximately 6.2 million unauthorized immigrants. Okay, so by how much does the formula underestimate or overestimate the actual number of immigrants shown in the bar graph? So in 2005, the bar graph says that there were 6.3 million immigrants. So that's 0.1 million or 100,000 that the model is underestimating. Underestimate by approximately 100,000. Okay, we want to use the model, the formula, to predict the number of immigrants for the year 1980. So this would be x equals -10, because it's 10 years before 1990. So I'm going to plug a -10 into my formula. So I've pulled up my previous answer here, and I'm going to replace all these 15s with -10s. -10 squared. And oops, negative is supposed to go inside the parentheses. All right, and enter. And I get about 1.2 million. And 2016, that is 26 years after 1990. So I'm going to plug 26 in. Replace all these -10s with 26s. And I get 11.5 million. Does the prediction for the year ending in 1980 seem plausible? 1.2 million. So let's go back to our data. So 1980 would be 10 years before 1990, so somewhere back here, being about 1 million, a little over 1 million, 1.2. Yeah, that seems to follow the trend of the data. That seems reasonable. Then let's talk about 2016. That predicted 11.5 million. So let's look at the data. 2016 is 9 years after our last data point, 2007. It's over here. And 11.5 million is like way up here. That seems like a big jump. It seems a little out of line with the previous jump sizes. So that might be a bad estimate, but it's possible. It's hard to know without having the actual data or data at least near 2016. So again, this is less plausible, not impossible, but I trust it less because it does seem like a big jump, and I don't have any data to verify. So sometimes a model, if extended too far beyond the range of the data, can lead to estimates that do not make sense or are unreasonable. And this is a situation we call model breakdown. So taking the fact that the actual number of unauthorized immigrants from Mexico in 2016 was 5.45 million, then our estimate of 11.5 million was very bad. So that we had a situation of model breakdown. The prediction made by the model did not match the actual number very well at all.